Hello, welcome back to Decaf-Math. How are you doing? I hope that you're having a wonderful holiday season and merry belated Christmas. So in my last video, I kind of mentioned the idea of radians and degrees in passing, and I thought that today we could come back to it a bit more. I think we're more familiar with degrees in general just because, in everyday life you can kind of use it more, I feel like, right? Like in snowboarding and stuff, you can do a 360. Well, I can't do a 360, but if you watch the Olympics and stuff, 360 is like a full circle, a full rotation, or maybe ice skating or something like that, right? Or if you're measuring, like, the corners of your room, they're all 90 degrees, hopefully. So angles, I feel like, are a little bit more everyday. But the idea of radians usually come up in trigonometry, and it's actually, like, it's supposed to simplify things, but I think the actual, definition and where it comes from can be kind of confusing, so I thought that we could go over that today. So just relax. I thought this could be fun. And, yeah, I hope that you find this interesting. Okay, so we're talking about radians. If you want, we could probably do a sleepy time video as well in the future, just straight up converting between degrees and radians. But for now, I just want to set up the idea, maybe mention the conversion and how they work too, but I just want to focus on setting up what a radian is. So you might notice that the word radian sounds a lot like the word radius. And so you might guess that this has to do with a circle, and you wouldn't be wrong. So, I'm going to just sketch a circle here. I don't have my compass on me. Whoops. Let's see though. Not too bad, right? Okay, so for circles, you need to have a center, and the radius is the set distance from the center to any point along the circle, right? That's that distance. And so with the center and a radius, you've defined a circle. The definition of a circle is the set of all points that are equidistant to the center, and where that distance is r, right? So I'm just going to set r. The actual value of this radius isn't important, though if you're interested, we could measure it. Let's see. Whoa, that's kind of cool. It's almost exactly 2 centimeters. That's cool. But it's not important here because it's all kind of just relative. So I'll show you in a second. So what I'm going to do is, this gets to be kind of like a chicken or egg definition. But basically, if I take this r, whatever the distance is, in this case 2 centimeters, and I wrap that around starting from this here, right? and I wrap it around the circle. So I'm tracing the circle here. And let's say I go exactly a distance of r. So, like there, okay? Something like that. I'm just eyeballing it. Now notice that I am not going straight, right? I'm still going around on the circle, along the circle. So if that distance is r, notice that there will be an endpoint right here, okay? Like from here to here. So this is the intersection on the circle. And if I drew this, okay, so if I just drew that radius as well, but if I just drew that segment, okay, do you see how this angle gets created? This angle gets created. I'm going to call that theta because in trigonometry we often use theta, right? So this angle gets created, and that angle, this theta, is 1 radian. 1 radian. The measure of that theta. So the reason I said it's kind of like a chicken or egg thing is, do I draw this picture with an angle first and call that theta and say if theta happens to be the angle that subtends, which is like a fancy word for saying that it kind of intersects the circle. Okay, so not the strict, but like the actual definition of an angle has to do with two rays intersecting, okay? But the two rays, which are just this, like you can keep going as far as you want and as far as you want here, but that will intersect this circle at this point and this point, okay? And that these 2 points will kind of cut out a piece of the full circle. So the arc that gets created, and that's what it means to subtend. Subtend. So if I start with the angle and I say if theta is the angle that subtends the arc that has a length of r, which is my radius, then theta is 1 radian. Okay, that's just like a mouthful. So the way that I like to think of it is if I trace out a distance of r, which is the radius, along the circle, the angle that kind of gets created from the 2 endpoints there, which is theta, is equal to 1 radian. Okay, you can just pick whichever makes more sense to you. It's the same thing. It's not really like an if statement. It's just kind of which way you think about it, right? But either way, it's all about moving distances of r around the circle. So remember, we're going curved. It's curved around the circle. So we're not doing this straight distance, okay? So I'm gonna just kind of because I think this part can get kind of confusing, so I'm just gonna like write it in pencil and erase it. But we're not doing this. Subtending means to go along the circle, so it's an arc length, okay? Not a straight distance. Okay, so why do we care? Well, it seems kind of convenient and cool that we just have 1 radian, so we're not working with like, 180 degrees. We're working with like 1 radian means 1 radius, a length of 1 radius around the circle. So we're thinking about things in terms of how many radiuses, radii. What? Radii. So we're thinking about how many radii around the circle and what angle gets created. Okay. So who cares? Well, there are some special angles we can think of that kind of help us visualize this further. Okay, so here's my egg circle. Whoops. Alright, something like that. Okay, so now let's keep this idea, okay? But there's a special case here. And the special case is we can either think of we could do 180 degrees, okay? But let's try, I'm saying degrees because we're more used to degrees, but how many radians is going a full circle all the way around? Okay, so let's say we took this part, so it's only going to look like this, right? But let's say we took this and went all the way around, so that we know is 360 degrees. But the question is, how many radians would this angle be? So if this angle is theta now, okay, so can you visualize that? It's actually an angle, but it's like taking this, so this one stays the same, but taking this one and sweeping it, moving it all the way around so that it ends up back at the first one. So it looks like this, but it's actually like two on top of each other, I guess, if you want to think of it like that, right? So it's like having gone all the way around back to the start. So that's actually an angle, theta. So let's think about what theta is in radians. So let's use our definition here where we think about what gets subtended, or rather how far have we actually traveled around the circle. So in this case, we're going from here at the starting point all the way around the circle. All the way around, right? And then we're back to where we started. That's technically the arc length that gets subtended because it's the start and the end here. Does that make sense? So the question is then, if a distance of r here, right, let's say that's a distance of r, gives me 1 radian, and then 2 radians, and then 3 radians, right? 4, 5, 6, How many radiuses, how many radii do I have along the circle if I go all the way around? It's an interesting question, isn't it? How many exactly am I going? If I say, okay, I take this distance and I kind of go here, I can go here, maybe here, right? How many exactly going along the circle am I expecting? Well, I know that the circumference of a circle, is 2 pi r. Okay, that's the general equation. 2 pi r. So the total distance all the way around is 2 pi r, which means, so what's the answer to my question? How many radii do I have going around? I actually have 2 pi of them. 2 pi radians. I mean radii. Radiuses. I have 2 pi of them. It's kind of like if I had 5r, I have 5 r's. So here I have 2 pi r's. So that means that I would expect, pi is 3.14, blah, blah, blah. So I would expect a little bit over 6. 1, 2, 3, 4, 5. Okay, I didn't do a good job with this one, so I'm gonna pretend that I didn't start estimating. I actually think that this radius is larger, so I didn't really account for that. It's probably more spaced out like this. We can do it more precisely next time. But we're expecting 2 pi of them, right? So going all the way around the circle, I have 2 pi r's. So that means that the angle is 2 pi radians. Isn't that so cool? So that's the convenience of having 1 radian, because 1 radian is the angle that gets created with 1 r, and we just found out that to go around the whole circle we have 2 pi r's, and so therefore it creates 2 pi radians. So 1 r means 1 radian, 2 pi r's means 2 pi radians. Tracing out 5 r's means 5 radians. See what I mean? It's pretty neat, right? It's convenient. Radians versus radius. So, then we know that 2 pi radians is the full circle, which we also know is 360 degrees. So that'll be helpful for our conversions between degrees and radians. But I really wanted to just focus on this part first, okay? Just defining it. So again, it is the 1 radian is the angle that gets created or drawn out when we move a distance of r, 1 radius, along the circle. If we create an arc length of r along the circle, it's the angle that subtends that distance, or that piece, okay? And then from there we can get these conversions. So, as you might imagine, since we're working with arc lengths, we're often working with multiples of pi, or we want something to do with pi. If you have some sort of number, like, I don't know, like 0.728 or something, or whatever, right? Usually you would assume that, like if you saw that theta equals this, you would assume this means radians, okay? And that means you'll probably want to convert that into something pi. Usually degrees will be written, 15 degrees, okay? So now let's just kind of mention that, let's see here. Let's kind of mention how to convert between the two. We've basically already set this up. If I write this, so let me just rewrite this, 2 pi radians is the same as 360 degrees. So usually that's the symbol, but I'm going to write it out this way so that we can see. So if we divide by 2 on both sides, notice that these two are equal, right? Kind of like if I wrote 1 yard equals 3 feet, right? They're equal. So I can divide by 2 on both sides. So here's our algebra. Right? If I divide by 2, I can divide by 2 on both sides. So the 2's cancel, and I get that pi radians equals, and then 360 divided by 2 is 180 degrees. And that's the conversion that we're going to use. So from here, pi radians equals 180 degrees. If you did the same logic that we've been doing for this, we could actually kind of show that this is true by doing the half angle case, so like a half circle case, right? So this is R and this is R. Then how far, what would this angle be? Right here, which I know is 180 degrees, is halfway around the whole circle. It's halfway around the 360. But then the question would be how many R's, right? To find how many radians, how many R's am I traveling to go halfway around the circle? How many R's? Well, if the whole circle is 2 pi R, half the circle is just pi R. So there are pi R's, which means pi radians, right? So pi radians is 180 degrees. And from there you can work through some proportions and setting up actual conversions, which I think I'll do in the next video. Okay? But a lot of times in trig classes, we kind of just jump right into this and say, okay, well, you multiply by 180 over pi, or you multiply by pi over 180. But I think it's more important to understand where it comes from. Isn't that kind of cool, though? The idea that we're going a length of R, an arc length of R, creates this angle of 1 radian. And then we're just basically finding how many radii are we tracing. And that equals the number of radians for my angle. Anyways, I hope that you find that interesting, or maybe sufficiently boring for you to just fall asleep. Thank you for hanging out with me. I love this kind of stuff. If you have any particular math topics that you'd like to do together, let me know. I'm working on a consistent filming schedule, and I'm gonna probably have a combination of requests versus just random topics that I feel like jumping around with. And I'll also try to do some more tutorial based videos and some sort of sleepy time videos. In either way, thank you so much for your continued support.